Hi and welcome to another edition of Math with Mr. Douglas. I have a feeling when this video gets published, this shirt will be see-through, magically. How does that happen? Well, I'm filming on a green screen right now that you can't see because it's been replaced. Yes, note to everybody out there, if you film on a green screen, do not wear a green shirt. All right, let's get to the math, shall we? Today we are looking at multiplying integers, learning the rules, and moving forward. Here we go. Today we're talking about multiplying integers. So that's what we're doing, and that's going to be the focus of today. And of course, we need some help. And some people were saying that they really did like when MathBear came along. So I'm going to go and draw MathBear right now. And here's MathBear, and you're like, how did you just do that with your, whoa, do you want to do that? That was kind of crazy. I have some really interesting kind of drawing stuff, so let's try and make this really nice and solid, and there we go. Now I should be able to go and paint bucket it. There we go. Let's get MathBear going a little bit, and MathBear, of course, needs some ears, doesn't he? There we go. And we'll just kind of shade those in a little bit. And there's probably some different colors there. A little bit. There we go. Kind of fill those in. And of MathBear, of course, he has little eyes, little black eyes, little black ones. I'm going to fill those ones in all at once. Kind of makes things a little bit faster. And let's get rid of this. We don't need that anymore, do we? Nah. There's his little mouth, and he gets a little thing like that. So that's MathBear. MathBear, of course, has he's gonna have a friend today because I thought, MathBear, I think he needs a friend. So MathBear is going to get MathBunny, and MathBunny is very, very cool. We like MathBunny. Whoa, that was way too bright. So MathBunny, let's try and get this going still. And you're like, I just want to learn the math, Mr. Douglas. You can be fast forwarding this. This is a great thing about videos, is that if you don't want to learn about MathBunny, you don't need to. That's the problem. I need to go and make this a little bit more solid. There we go. That's pretty solid, right? For bunny ears? Yeah, we like that. There we go. It's not very good. But you get the idea. It's a whoa. It's kind of white. And we're talking about a bunny. You need some pink in there. Right? There's some pink inside the ears. There we go. And MathBunny, of course, has, again, little eyes like this. And he's got a little nose. His nose is probably pink. And it kind of goes down like this. Whee! You know, a little red tongue there. There you go. There's his little tongue. And he's a bit shy, so he has kind of like a... There we go. You could probably do a better job. So these guys are going to go and help us out today. So MathBunny and MathBear, they're going to go and help us out a little bit. And we need some rules. We'll get straight into the rules. And the rules are pretty, I think, straightforward. So we're talking about multiplying. If the signs are the same, so that's the key. If they're the same, your answer will be positive. So I'll say it equals positive. Nice and simple. And the second rule, of course, is if the signs are, yes, you guessed it, different. So if they're different, the answer is negative. And that's really it. That's not too bad, is it? Oops, let's make negative into a blue color, because for some reason we associate negative with cold, and cold is blue. So it's negative. So there you go. Those are the two rules. MathBear and MathBunny are pretty happy with those rules. Let's go and see some examples. So here are some examples. Let's just start off with nice and simple stuff. Let's say we had 8 times 7. So that's what we're talking about, 8 times 7. And remember, this idea is basically like multiplying is really repeated addition. So this is saying 8 groups of 7. So, if you actually had 8 groups, 1, 2, 3, 4, 5, 6, 7. Oops, 1, 2, 3, 4, 5, 6, 7. Oh, we need 8, right? I said 8. So let's get 8. And there's 7 things, right? So like 1, 2, 3, 4. I should make this small numbers. 4, 5, 6, 7. And there's like 8 groups of these. I'm just saying, how many things are there? All right, and you could also just say 7 groups of 8. You could also do that. So that's what we're doing, and you've probably already seen this from your earlier math teachers, and they maybe did a better job of of explaining this. But that's basically what we're saying: repeated addition. So how many stuff are there? It's like, whew, there's a lot of things there. Thank goodness we figured out multiplying. And your answer is going to be 56. There's 56 things. Think about this, though. This is what I want you to think about. So this is the big things. Like, what kind of number was this? It's a positive number, wasn't it? It was positive 8. What kind of number was this? It was a positive 7. So they're both positive. They have the same sign. So same sign equals positive. Positive, like that. But what happens if they have a different sign? So let's just say that we had a negative 8 times 7. Okay, so there's still going to be 56 things. There's still going to be 56 things. But now when you're asking about the sign, what kind of sign is this? It's negative. What kind of sign is this? Well, it was positive. So it's different. So different signs equals negative. So my answer is negative 56. You with me so far? Awesome. So let's go and say the other kind of interesting one, which of course is if they're the same signs, but so negative 8 times, we'll put this in brackets to make it look very clear, times negative 7. So we still have 56 things. We still have 56 things. But when you say what kind of sign was this, it was negative. What kind of sign was this number? Negative. They're the same. So a negative times a negative is going to be positive 56. What? How does that happen? Well, I could go into a huge thing and bring in Math Bear and Math Bunny and explain it to you. Let's just go with memorizing the rule for right now. So a negative times a negative is a positive. Now, you're like, okay, I got that one. Where does a common kid mistake come in? Because the common kid mistake, okay, that's where we need to go and get Math Bunny. So here's Math Bunny. And Math Bunny is going to talk to us about the common kid mistake. Okay, he's going to help us out because I'm going to show you where most kids end up making a little bit of trouble. And it's very common, hence I call it the common kid mistake. So first off, let's get Math Bunny all here. Let's get whoops. Math Bunny. There we go. Get this. Get his little button nose, and he's happy. I think Math Bunny is always kind of happy. And he's got his little eyes. His little eyes. And of course he's maybe blushing a little bit. There's some nice little blush. Okay, so Math Bunny is going to go and talk about the common kid mistake, the KM. And this is it. Let's go and use very similar numbers. Negative 5 times 4. Negative 5 times 4. So this is what kind of happens. Actually, let's make it negative 5 times a negative 4. Hope that didn't ruin your notes that you're taking, as all good students do. Negative 5 times negative 4. So you're doing this question and you're like, okay, I just learned the rule. They're the same signs, so my answer is going to be positive 20. So there we go. You gotta remember that positive 20. But then this is what happens, is kids get the next question. So the next question they get is very, very similar. But it says this, negative 5 plus negative 4. And kids think, okay, so So, it's plussing. So I know it's going to be 9. And they're both negative. And when the signs are the same, the answer is positive. So it's going to be positive 9. Yep, that's it. Yay. And that's when Math Bear is going to come in. And Math Bear is going to be like, Math Bear is sad. Because it is not positive 9. It's going to be negative 9. I want to make this very evident that the rules are different for adding and subtracting than they are for multiplying and dividing. That is where kids will mess up on this. So the rules for multiplying are as follows. Same sign, going to be positive. Different signs is going to be negative. But when it came to adding and subtracting, go watch my earlier videos and you can go and figure that out. When the signs are the same, you add and you keep the sign. So that's why this was negative 9. So very, very important that you know the differences there. The fun continues. Yes, the fun continues. We have some other kind of special things to talk about, and we're going to talk about powers. Yes, we're going to bring out our superpowers. Powers, or also known as exponents, also known as the index, look like this. 5 to the power of 3. So the power is this thing right here. It's really tiny and it lives in the upper right hand corner. And what this really means is 5 times 5 times 5. It's like repeated multiplication. So I'm going to multiply 5 3 times by itself. 5 times 5 times 5. So that'd be like 5 times 5, which is 25. 25 times 5 is going to be 125. So that's your answer. And I would say 5 to the power of 3. 5 to the power of 3. Okay, that's how I would say it. 5 to the power of 3. And that's what it means. Now, that doesn't seem too bad, but there's some tricks to this one. There is definitely some tricks that we need to kind of pay attention to. Let's just do a couple more examples of some basic things, I would say. So let's say I had 3 to the power of 2. So 3 to the power of 2 means 3 times 3, which is 9. Now this brings up a really good point. You're like, what did he just do there? What is that? It's a dot. A dot means to multiply. Multiply. So no longer is it just the x, which means multiplying. You can have a dot. And, really advanced, if you have numbers beside a bracket, it also means multiplying. What? Yes. There is a hidden, there's a hidden multiplying sign right there. Multiply. So that meant 3 times 2 right there. Boom, 6. Okay, so different ways to multiply. So 3 to the power of 2. Okay. Well, what about this one? Let's start with nice and slow. I'm going to use brackets. Now, brackets are going to be really, really important. What if I said negative 3 to the power of 3? What does that mean? Well, that would mean negative 3 times negative 3 times, you got it, negative 3. So what would that equal? Well, always start left to right. What's negative 3 times negative 3? They're both negative, so your answer will be positive 9. And then you'd have 9 times that negative 3. And I'm just going to use that beside thing there. So 9 times negative 3. They're different, so my answer is going to be negative. And that's going to be negative 27. But, look at this one. Now this one always gets kids. What's negative 3 to the power of 3? Now quick, what do you notice difference between this question and this question? What do you notice? Why, yes, you're absolutely correct. It doesn't have a bracket, does it? No. Does that make any difference? It absolutely does in terms of how we look at this. And this is weird. This says take away 3 to the power of 3. Take away 3 to the power of 3. So when you go do it, it's like take away 3 times 3 times 3. That's really what it looks like. So that's interesting. So that looks a lot different than this, doesn't it? And this is where one of the common kid mistakes kind of comes into it. We still kind of work the same way. This is like a negative 3 now, times 3. So that's going to be still, that's going to be a negative 9. And so we times that positive 3 over there. So we're still going to get negative 27. But I wanted to show you how that looks different because of the following next example. What number shall we use? Think of a number right now and see if I use it. Okay, got it? Cool. I'm going to use the very popular 5 to the power of 2. And I'm going to make it actually negative 5 to the power of 2. Negative 5 to the power of 2. And over here, my other question, I'm going to use the exact same thing, but I'm not going to have brackets. And let's see what happens. Negative 5 to the power of 2 just means negative 5 times negative 5. Remember, if two things are kind of touching each other, that means we're kind of multiplying right here. There's an invisible multiplying sign. What's a negative 5 times a negative 5? That's going to be a positive 25. Over here, though, this says take away 5 times 5. What's that going to be? It's going to be a negative 25. Different answers. This one's negative. This one's positive. Will a math teacher put that on a test somewhere? Absolutely, to see if you understand the difference of evaluating powers. And that, students, is an excellent thing to know. In the next section, what we are going to explore is multiplying rational numbers. Yes, we're going to be looking at fractions. Here we go. So the board game you saw there is Risk. And Risk is one of my favorite board games of all time. It's all about dividing and conquering the world. So hence me using it. Get it? Dividing, conquering, multiplying, dividing, all that kind of fun stuff. So that's the board game. I highly recommend it. Let's go and bring back our Math Bear and Math Bunny. There we go. We're going to be talking about multiplying fractions. So luckily we have Math Bear and Math Bunny. They're experts. So Math Bear and Math Bunny, what are the rules there? And they go, "Wow, Mr. Douglas, the rules are..." Yes, that's my Math Bear and Math Bunny voice. I'm sorry if I just hurt your ears. So what are the rules going to be? So the rules, and I'll give you the kids' versions of the rules. Here we go. Number 1. Multiply across the top, comma, and bottom. Okay, so you can do that. And the second thing is you're going to simplify. Which means, what does that mean? It means dividing by a common factor. That's what that means. And I'll even give you a little bonus. Cross reduce first. Cross reduce first, if possible. Okay, so there you go. So if you had all that, then Math Bunny and Math Bear would be very, very happy. So on to some examples. Because examples are the key, are they not? I think so. So here we go. Let's go and do 10 over 12 times 3 over 4. Now this is a really fun example to do, because I'm going to show you this question done a few different ways. It's all going to get the same answer. So we're going to do this, I'm going to do it 3 different ways. Okay. Let's just start down below here, and let's just do it the straight up way. I said you multiply across the top, like that, and across the bottom. Feel free to use sound effects. So what you end up getting is 10 times 3 over 12 times 4. So that would give you 30 over 48. Now I also said you had to go and reduce, simplify, which means dividing by a common factor of 30 and 48. So the greatest common factor, the GCF of 30 and 48, I think, let's see, is it going to be 6? Yes, it's going to be 6. So I divide both by 6, and then I end up getting 5 over 8, and that's my final answer. Now, let's go and simplify first. So back over here. So you look at each individual fraction and say, could you simplify this? Could you divide 10 and 12 by a common, like a GCF? Why, yes, you could. Could you divide these by 2? And that would become a 5, and that would become a 6. So now I have 5 over 6. Could you also do that to the 3 and the 4? No, that's just the way it is. Okay, so now you get 5 times 3 and 6 times 4, wouldn't you? So you'd get 15 over 24. But you say, oh, can I reduce that? You divide by 3 this time. And oh my gosh, I get 5 over 8. Like that, right? Cool. Now the last one I'm going to show you is the most efficient way. I'm going to use different colors. I'm going to do the same thing here, 10 and 12. So that became 5 and 6. But, and let's just make this look pretty cool. So 5 and 6. But now I'm going to cross reduce. Cross reduce means I'm looking this way and I'm looking this way. So I'm going to go and cross reduce. So 3 and 6, do they have a common factor? Oh my gosh, they do. 3. So I'm going to divide this by 3 and divide this by 3. And now my new awesome question is going to be 5 over 2 times 1 over 4. And so that means, 5 times 1 over 2 times 4. So that will be 5 over 8. So cross-reducing and simplifying, all combined with multiplying fractions. Now, of course, we still need to remember our basic rules of negatives and positives. So if I had like negative 2/7 times, let's say positive 3/10. Negative 2/7 times positive 3/10. So again, I would definitely go and simplify this. So I would do 2. Remember, you're looking at this as a cross-reducing. That would be a good one. So negative 2 and 10 have this become a negative 1. This becomes a positive 5. So now this is negative 1 times 3. So this is negative 1 times 3 over 7 times 5. So it becomes negative 3 over 35. That's your final answer. Again, if you had stuff like this, maybe you had negative 8 over 15 times, let's say 3 over negative 20. I would do my cross reducing. So 3 goes into 3 once, 3 goes into 15 5 times. I would also cross reduce the other way. So negative 8 and negative 20. So I divide both by 4. This become negative 2. And this become negative 5. Now over here, so what you end up getting is a negative 2 times 1 over 5 times a negative 5. So you get a negative 2 over a negative 25. Now, notice you have a negative over a negative. They're both negatives. Remember our original question was a negative number times another negative number. So that's going to give you a positive answer of 2 over 25. Thanks everybody for tuning in to another edition of Math with Mr. Douglas. Hopefully your multiplying is A-OK. Until next time, have a great day.